going to do? Remember, you have the exam next week, exam 3. Later this evening, we will review for exam 3. We're going to have a homework quiz in just a moment, so go ahead and start putting your computers down and putting your notes away. And then we'll have lecture lab, which will, first of all, consist for reviewing for exam 3. And then hopefully we will get to structs tonight. Structs is a larger topic, so there's multiple pieces of structs we'll talk about. We'll talk about simple structs, straightforward structs, and we'll talk about the various permutations and additional things to get to with structs. Okay, who found that quite easy? Really? Only a third of you? Wonder why they came in so fast. I guess if you didn't know it, you might as well turn it in. Okay. Okay, hopefully that was easy peasy. Should have been. Because you should have had all the knowledge to actually complete that test before last week. I didn't tell you anything last week that you hadn't already heard except the slight fact that you could have figured out that you can call a function from within itself. That's just the definition of recursion. But that's the only additional fact I gave you last week. All right, we're going to start reviewing for exam 3. Exam 3 is next week. Same format. We're going to review for it now. Hopefully that won't take the whole class. We'll start talking about structs. But we'll review for exam 3 first. You might need to know this. And we're going to review for exam 3 first. At the beginning of class, everybody will be able to ask at least one question, one specific question. Not show me an example of, but a specific question. So, keep track of who's next as we go. When you write a function, let's suppose I'm going to write a prototype of, okay. So, this is a prototype. You can tell it's a prototype because the body of the function is essentially that semicolon, i.e., in other words, it has no body. Okay? So, what are the possible return types? Because the signature of a method is return type, method name, and then parameter list, right? Okay. What are the valid return types I can put here? You can refer to them as a class, or what are valid return types? Valid return types. Just pick one. No, a valid return type. Okay. Void. What does void mean? It doesn't return anything. It doesn't return null. It returns nothing. In other words, it would be invalid syntax to assign the result of a call to my function to anything. So, another type.
Integer.
Yeah. One more.
Float.
Float. Next. What's another valid return type?
Character.
Can you remember?
Double.
Double. And the list goes on, but there are single return types. Since we haven't talked about structs, we won't get into that. Sure.
Can you return a pointer?
You can return a pointer.
Where do you put the star for that?
Right after the type.
Thank you.
Good question. Excellent question. Okay. So the point is you can return any type, including pointer types, from my function. And you have to, when you declare the function, and when you give the function definition if you're using a prototype, you always have to give some type, even if it's void that says I'm not returning anything. Now there's a wrinkle here. void says I am not returning anything. So let's suppose you put void my function. If you said int a is equal to my function, I hope you will get a syntax error. I don't know for certain that you will, I'll test it. But I hope you will get a syntax error. Now, there is a wrinkle here, and I'm going to tell you the wrinkle, although it's not, well, I'm not sure it's crucial for this class or not. But if you say void pointer, that is different. Because that is actually saying I'm going to return a pointer of an unspecified type. When you say void pointer, you're actually going to return something. It says returning a pointer whose type is not specified. Definition of the language. There are actually valid and good uses for that. So that's first piece of review. You have to signature of a function. You can return, you have to return some type, even if it's void, and you can return any of the valid types, which are the types we've talked about, and or pointers to those types, not more. And pointers to those types is in the list. Okay, what's a prototype? It is a signature of a function with no body. In other words, and it has a semicolon at the end. That is a prototype. Who's next? Why would you use a prototype? Okay. Let's just put a quick example up here. Will that compile? Same person. Why would it compile? It won't. I'm curious why you think it would compile.
Oh, it wouldn't. No, it wouldn't, because the int new function doesn't have the a. If you put int a equals new function.
This doesn't have a. Now this is a perfectly valid function definition in and by itself. But you're right, it would not compile. Okay, next. Why would it not compile? This is an easy question on the coming exam. Right here, on the coming exam. This is one of the easy questions, just so you know. Why would that not compile? Why would that not compile?
There's no semicolon at the end of the
That, you mean here?
yeah, there's no semicolon.
No, you get a syntax error to put a semicolon there. Why would it not compile?
Because the scope, you don't have int new func before the first.
That's correct. At this point, when the compiler gets to new func, it says, what's new func? I've never seen new func, because the compiler compiles like this, top to bottom. How could we solve this problem? Yes. How do we solve the problem that this will not compile? Because at this point, the compiler has not seen anything called new func, so it has no idea what to do.
New func in a scope that's the same as wherever int a is.
So what do you, I'm sorry, tell me one more time.
Would you just try to arrange the brackets such that new func, when int a equals new func and int new func, they're in the same scope?
No, okay, let me ask the question differently. Without changing any of this, but only adding to it, what would you do?
Would you put a into the parentheses?
Nope. There's nothing wrong with int main. There is nothing wrong with int new func. In and of themselves, they are fine, except for the fact that at this point, the compiler, and consequently main, does not know what new func is. How do we solve it?
You need to use a prototype to declare the new function
That is correct. And where would we put it?
above int main.
So, as usual, my white space management skills are poor. I just rewrote main. I didn't do anything. I just moved the slide. Okay, now where would I put it?
You put int new func and then the parameters
Where?
above int main.
Oh, it has no parameters. That's why I did that, to make it easy. That's correct.
Why write the prototype and not just the whole function?
Remember our discussion of header files? In header file, okay, who knows what goes into header files? What goes in the header file? Just the header file. What goes in? Okay, hold on. Back there.
The library name.
No, that's what the header file ends up telling the compiler to invoke.
Are header files not like studio.h?
Okay. Let's back up and review header. That's okay, we'll come back to this. We'll back up for a minute, review header files. Okay. This is what you have put at the beginning of almost all of your programs. Is pound, or hashtag if you like. Hashtag is probably the more current thing. But in the programming world, this is referred to as pound, right? Even new hires walk in, because we only hire people who know what they're doing. They don't refer to this as hashtags. They refer to it as pound. That's the programming name for it. Pound include stdio.h. That is at the beginning of almost all of your programs. It is not magic. That include allows you to use, next person, what does that pound include allow you to use in your program? Scanf and printf, etc. Means there's more in there besides scanf and printf. Sir?
Wait, so the header file only contains the prototypes of those functions, right?
That's exactly correct. I'm just going to give you an example of what stdio.h will contain. 1 second, let me write this down, then we'll come back. And I don't remember the exact prototype of these, so I'm just going to put something in like an example. Dot, dot, dot is actual syntax. It is not my way of saying more stuff. It is actual syntax that says there's going to be a variable number of parameters of different types. So I happen to remember how printf is, the parameter list is clear. But the key point is, it is only the prototype, which means it is just the name and a semicolon. And let's suppose that scanf also returns, also returns an int. When I say character pointer format, that's effectively saying a string. So remember, when you use it, you give it quotes, whatever you're going to give it quotes. You don't have to. You could make a character array and put some quoted string into it and then pass that character array as a parameter. That's perfectly fine. Okay? And then there are more things in here, like getf and putf and things like that. Okay? So the bottom line is, when you say pound include stdioh, it has this, and it just textually includes it. There's no magic here, right? It just says, go read this file and stick everything in that file at the beginning of the program for the compiler to read. Then the compiler reads it, and the compiler knows about printf, scanf. He knows what the parameters have to be so that the compiler can give you a syntax error if you don't give it the right parameters, and all the others that you can use. Okay? This is the purpose of a header file. Yes, ma'am.
This might be a dumb question, but in the textbook it mentions something that without, say, like the preprocessor directive, which is standard input-output header, like printf and scanf can't exist.
They can, but they get compilers.
Can you explain, like, I don't know how to say this, but why that happens? Like, why not without studio.h can we use?
Okay. Printf and scanf are not parts of the language. Go back to your first night. Those of you who took notes will see that I wrote syntax, I wrote or language. I'll probably put language. I then put libraries, and then I put IDE for Integrated Development Environment, essentially an editor. And Notepad's a fine editor. is an editor, right? Anything you can type into. Okay. So language is things like how to declare a function, the known types. That's part of the language. Okay. Printf and scanf are methods in a library. They are not part of the language. They are methods in a library. And by the way, this is how all programming systems work. That's not true. Well, yeah, actually it is. That's how all programming languages work. Now that I think about it. Okay? In one form or another. Even in COBOL, you do this. You just do it less elegantly, but you still do the same thing in COBOL. So printf and scanf are methods. The compiler does not know about any methods. The compiler only knows about int, float, character. The compiler knows about how to declare a function. The compiler knows about syntax to do addition, subtraction, and so forth. Syntax to compare two things. When you get right down to it, the language itself, what the compiler knows, because the compiler just interprets the language that you've written in your file, is relatively small. It's a small set compared to the number of functions that have been written into libraries that you can use. Printf and scanf are methods. If you don't tell the compiler about them, when the compiler sees them, they'll give you an error that says unknown identifier or something like that. So that's how header files work. It's okay, because we have to review this anyway. We'll get to it now. That's how header files work. This lets you use scanf, printf for this case, right? And there are other libraries. There's stdlib.h, standard lib, that contains string functions like string compare, string copy, strcmp is string compare, strcpy is string copy, and so forth. Lots of libraries that contain lots of methods and functions. For your purposes, you have to understand the difference between a language and a library. And to use the library, you have to tell the compiler about the methods that library contains. And you do it by saying pound include, stdio, or whatever the name of it is, .h. Now you don't have to use .h. There's no magic here. It will include whatever name you put here, right? It simply has to find the file. The reason we use .h is because it's referred to as a header file. A header file contains only prototypes. A header file should only contain prototypes. That's not entirely true. Yes?
So are methods like printf and scanf recursive then?
No. Recursion has nothing to do with this. This is just defining a prototype so that you can then use it later. Now the fact is, you don't declare printf yourself because somebody has already declared it, written the function, the body of the function, and compiled it into a library. And because you put pound include stdio.h, the compiler is going to know to go find a file called stdio.dll. DLL stands for Dynamic Link Library, and that is where the functions are. And if you look back in your notes, when I told you about how a compilation actually works, it does the syntactic compile, and then what's the next thing it does? Somebody look in your notes. No magic. You do a compile, and there's another step.
You need a linker?
Linker, that's exactly right. The linker is the thing that takes these functions that you said are in another file and resolves the references where you use them. So that's how, this is why I have to tell you how stuff works, so that you understand the reason for doing it. Because the original question that got us here, and I forgot who asked it, was, why do you use a prototype instead of just defining a function? Who asked? Okay. Why Why do you use the prototype instead of defining the function? So remember, I've constantly said this in the class, we're doing small, trivial things so you learn the language. But think about a program that has hundreds of methods that you write. You obviously don't want to stick them all in the same file. That would be organizational suicide. It would be like taking 20 years of tax returns and putting them in no particular order in a single folder. And then the IRS guy comes to audit you. Not a good thing. So you organize things. Right? You would break hundreds of methods up into logical files. Just like implementers of standard C did. They said, okay, all the standard I/O files, I'm going to put in one file. Then they said, we're going to have standard live. And they put a bunch of stuff in that. And then they realized, uh-oh, we were a little short-sighted. We're getting too much stuff into standard.live. So they started breaking it up into other files, string.h, so forth. There's advanced I/O whose name escapes me right now, but it has advanced functions. There's a lot of header files, right? So think about you're out in the real world, writing your program to land the new moon lander on the moon, and you're going to have a lot of functions because you're going to have radar inputs, you're going to have gravitational inputs, you're going to have speed inputs, you're going to have all sorts of inputs. Then you're going to have to do all sorts of calculations to figure out, am I going to land this softly, or am I going to do the equivalent of a faceplant? We don't want to do the equivalent of a faceplant. So, your program, your C program is rather large. So you have to break it up into pieces. So you break it up into pieces, and then pieces that use other pieces refer to those other pieces by header files. And the header files simply have the prototype of the methods. So that is why you would use prototypes. The other problem is, think about this, right? Suppose A calls B, and in other instances, B calls A. Is there any way without using prototypes you could define that? You can't declare functions inside functions. It's a flat structure. Again, we're going to do something simple. We'll work in another review topic here. Okay, let's suppose you had a program. You had a method called A, and that method calls B. As it happens, you have the function B, which happens to call A. Is there any order in which you could declare A and B that would not give you a syntax error? No. You would have to use a prototype. That's another reason to use a prototype. Straightens that out. Now, so while we're here, I found another review opportunity. I have declared the variable temp inside of A. I have also declared a variable named temp inside of B. Why can I do that?
Because of scope.
Yep. Go ahead. Keep going. What is scope?
Well, scope it means that if you have a variable declared inside of one set of braces, it's not going to be it's going to be like that name only applies inside of that set of braces. It doesn't apply outside of the braces.
That's exactly correct. Well said. Inside the set of braces is where that variable is visible or has scope. Outside of those braces, it's as though it doesn't exist. That's why I can name two variables inside different sets of braces the same thing, because they're completely different variables within their scope. Okay, they worked in scope there. Okay, so let me back. This is called popping the stack, right? How did we get here? I told you how, remember I showed you how things execute? Method call, I'll tell you again later. Okay. This is how we got here. You can declare prototypes. Now hopefully you know why you would declare prototypes, or some of the reasons, right? Some of the reasons are you have to, because there's no other way to do something like this. Some of it is organizational. Most of it is organizational. To put things cleanly together in big programs, or libraries that other people are going to call. Because you can write libraries that other people are going to call. You have a big team, right? The big team working on the moon lander, right? And this team says, okay, I'm going to make a library that calculates orbital rates. You have another team that is doing spacecraft control. This team doing spacecraft control needs to be able to calculate orbital rates, so they just call the functions the other team makes. The other team simply puts it in a library and gives them a header file. Then they say, okay, fine, we'll just use your library and get the value back. We don't need to calculate it, you've already done the work for that in the other team. This is literally how the real world works. We have all sorts of people that write functions in the data to access the database. I just use those functions. Sometimes I have to write temporary functions to access the database until those people can integrate that work into their libraries in whatever fashion is more appropriate for them. But I do it so I can get my job done in the short term. They will eventually integrate it into their library, and then I remove my code and just call their library. I wrote code this week that's going to do exactly that. I wrote code, I wrote the database stored procedures and everything else, and eventually the database team will take that functionality. They will take the signature of what I put to get the method, and they will include that in theirs, and I'll erase mine and start using theirs. Now eventually maybe 3 or 4 years, but it may be somebody other than me, but it will happen in most good organizations. Okay, as an aside, someone earlier muttered to themselves, well, it compiles so it must work. So whenever that person said that, I felt compelled to put this joke down, because this is a joke, a poster you will see lots of places. There was a beer commercial where an old guy, when I say old guy, you know, it might be my age, sorry. Old people don't think of themselves as old, you know that, right? We think of ourselves as just slower than we used to be, but we're not old. Okay, old guy, and he's sitting there, and he frequently has 2 attractive women, he's frequently doing some sporting event or something, right? To say he's a dynamic guy. And his line in the beer commercial is, I don't always drink beer, but when I do, I drink Dos Equis. So, everybody, a lot of people, and this is a picture of the guy, let's say, they made posters and pictures and things to be distributed of the old guy with their own saying that always starts with, I don't always something, but when I do, so these are the key points that are in the thing. I don't always, but when I do. And then the joke is to put things after it, right? So one of the programmer jokes that all of us programmers have is, I don't always test my code, already a no-no, but when I do it in production. Right? That's the joke. Think about it, right? First of all, you should always test your code, you know, and for goodness sakes, never put it in production without it being tested, right? But this happens. Sorry, what? Sorry, go ahead.
I was just muttering something to myself, but too loudly.
Question. Could you define production in this
Production is what the real world sees, okay? So you go to Facebook, that's production. You go to Google, that's production. You go to any website, that is the production website. Now at Facebook, Google, Amazon, wherever you're going, okay, they are doing development. They do development on their local machines, and they test it out there, and everything's good, right? Then they'll move it to a QA environment. QA stands for quality assurance, okay? And it's important to have QA people. I seem to be the sounding board for our QA team. I think the rest of the developers frustrate them because they don't talk to them for some reason. They do. They do talk to them. I talk to them with a sympathetic voice, knowing they have a hard job. So quality assurance, we build it and we check it in. Something called, in other terminology, we do a push, a code push, to an environment, to a source control environment. That's where the code sits, and it's compiled into a QA, a quality assurance environment. And then the QA people come in, they read the requirements of what you did, and then they test those requirements, right? Frequently those requirements, well, the requirements are clear, and then there's another section that says acceptance criteria. This has to happen, this has to happen, this error condition is caught, whatever it is, okay? And the quality assurance people test that in the quality assurance environment. Because the developer's done, we hope, and we'll never touch it again. Because when quality assurance tests it, if they find a problem, they write a new thing called a bug, which is a problem. And then it goes back, hopefully, to the developer that created it. I was religious in whoever broke it, I don't care if it's 5 years later, you fix it, right? It's a self-correcting algorithm. If he writes a lot of bugs and he's busy fixing his bugs, he's not busy creating new bugs. Self-correcting algorithm, wonderful things. But that can only go on so long before somebody says, what should we do here? Okay. After the QA environment and the QA people have passed it and are happy with it, it goes to another environment that's called different things. Sometimes it's called UAT, which stands for User Acceptance Test. Sometimes that environment is called Stage, which is a staging area before putting it into production. Sometimes you have User Acceptance Test and then Stage, which is just part of the release process. But then in the User Acceptance Test, developers and QA people aren't testing it. Non-IT people are testing it. So like program managers who said, I want this feature to do blah, blah, blah. And he said it in English. He translated it into code, but he said it in English. So he goes to the website just like a user would and tries it out to make sure it does what he thinks it should. And if it doesn't, a bug will come back from that, which means one of two things. QA didn't do an adequate job, or the requirements were not adequately written. Frequently, requirements are not adequately written, but that goes back to the developer for not raising his hand and saying, these requirements aren't good enough. Just like you guys come and ask me about requirements, and frankly, I edit them sometimes, because you make good points. Yeah, I could phrase that differently to be more clear. It's okay. That was probably a long-winded answer to your question.
It's okay.
So the last thing is production. Production is what the real world sees. Users of whatever the system is. Be it a medical system for taking down your symptoms and the drugs you take and all that stuff, or be it Facebook for connecting with half the world, or be it Twitter for connecting with the other half of the world, whatever it is. That's what production is. So, this is one of the standard jokes. I don't always test my code, but when I do it in production, right? Because the old guy in the beer commercial, he's doing extraordinary things. Right? He's the first guy to travel to Mars and things like that. Well, look it up. I forgot the name of the commercial. Well, look up. I don't always. Google it.
It's the world's most interesting man.
Thank you. The world's most interesting man. That's exactly what this guy is referred to as. The world's most interesting man. Look it up and see some of the jokes from it. But remember this joke, because this joke is a lesson, right? I say this joke all the time at work, jokingly, right? But if I say this to someone in a non-joking way, it's because they did this. And there's going to be consequences. Every time if it's me. Unless they're fresh out of college. Well, if they're fresh out of college, it's my fault because I didn't teach them something. Okay, that's your aside for today. The anecdote, but there's good lessons in it.
Is there an umbrella header file for everything?
Nope.
Since everything.
Nope.
Nope.
Nope. You figure out what you need and you include what you need and only what you need.
Is there a limit to how many header files we can put in a program?
It probably is. I don't know what it is, but if you're using that many header files, you didn't adequately organize what you're doing.
Why is that?
Because you don't want one big monolithic thing. You want things broken up into pieces. Orbital mechanics, thruster firing, landing gear down, break it up into small pieces.
Similar to his question, if you have a lot of prototypes, does it slow down the code because it constantly has to check?
Not a bit.
Okay.
Because the compiler resolves all that before you run your program.
Oh,
In other words, the compiler resolves all that in creating the executable.
Okay.
So it will not slow down the executable at all. So while we're talking about functions and breaking things up, who remembers that acronym I told you about? DRY, dry. Don't repeat yourself. That's one of the reasons you use methods. So you don't write the same thing over and over. You write it once in the method and then call the methods. That's exactly right. Don't repeat yourself. There's another one for you. They actually ask you these questions in interviews, by the way. I'm not sure they should, right? They should ask you why do you use a method? But too many interviews will say, what does dry mean? Who cares, right? The point is, use methods and break things up. KISS is another common acronym. Stands for Keep It Simple Stupid. They had to find another word to go to the last S, right? What that means is, keep it simple. Make it clear. All right, any more questions about prototypes? Functions, breaking up functions, how you use them. We're going to do more about methods and functions in a second. Any questions about any of this so far? When you have a prototype, what is the signature of the definition of the function have to be?
Either int A equals B or double.
What do you mean either?
You could choose one of those.
No, it has to be identical to this.
Oh.
Identical. Because it's going to be the same thing, except instead of a semicolon, you're going to put a body to start and end with a brace. But that's the point. The prototype has to be identical to the definition. Because if it's not, you've prototyped something else, as far as the compiler is concerned. If you call it A up here, and then write a function called B down here, there's no way for the compiler to say they're the same thing. Question somewhere.
In one of my codes, I didn't put the semicolon at the end, but it just still runs through now if it's on a set of thing.
That's a specific question. Ask me a lab time. I don't know. So I doubt it, but I have to see the specifics. Okay. So in my function, this is too easy, but in the function I created called int newfunc, what keyword do I use to exit the function and return a value? Return. That's why it was too easy. There's only one choice, right? So even if it's a void function, you can say return semicolon without returning anything. That just exits the program. It exits the method. You don't have to use return. You can just, if it's a void function, you can just let it go to the bottom of the last brace and it returns anyway. But typically most people say return because most things are returning a result of some type. But if it is void, you do not have to. Here's the bad news about C. Even if you have int new func, you do not have to return a value. And the results are undefined. Sadly, there are a number of things in the C language standard that say you can do X, Y, and Z, but the results are undefined. It will compile, but you'll get undefined results. Now, in the modern compilers, you will get warnings and all sorts of things, because they're a lot more intelligent now because we have a lot more processor memory and so forth, right? But the C standard says you can do that. You don't need to worry about knowing that. For your purposes, just like I told you never use a goto, you should know what a goto does when we eventually get to that, right? But you should never use a goto. You should never not use a return, just for clarity in your programming. Everything about pointers we already talked about, remember, it's the basis of a lot of what we do. So go back and review pointers, review references, review the fact that arrays are in fact reference type variables, that an array name by itself without a subscript is by definition of the language a pointer. Go back and review all that stuff. Okay, any questions so far? Sure.
So if you're returning a void type function, will it compile it or is it
So let's suppose I said void right here. The compiler should return an error. I don't know that all compilers do. You should return an error. What you should do, in the case of a void function, is just call return without any value. Sure.
So in a void function, you still want us to put a return?
You don't have to. I highly recommend you do. Like when I said, if you don't use braces, you'll get a 0. Strictly speaking, in the C language, you don't have to use braces, but that point is so important, that's why I'm giving you a 0. If you use a goto, I'll give you a 0, right? Because you should never use gotos, even though technically in the language you can, right? This is one of those where it's perfectly valid to run out the end of the method.
So we won't print 0?
No. Unless you should have used a return for another reason. Like you should have used a return to return the particular value. If it's not a void function, yes, you should always have a return. Even though the language spec says you don't have to, you've written an undefined behaving function, right? You'll get a 0 for that. On that question. But by the way, I have lots of opinions about programming and this and that and the other. I don't tell you most of them. I only tell you the ones that would cause you to not be hired if you got in front of on a whiteboard and you did something, right? If you wrote an if statement without braces, most places would not hire you. They would say, he doesn't get it. If you used a goto, they would absolutely try and contain themselves, but they still would not hire you. If you wrote a function that just naturally goes out the bottom and is void, doesn't return anything, they generally won't care. I would hire you if you did that. Right? That would not be a hiring decision. I might talk to you about it later, but because that's a trainable and teachable thing. That's okay. It's not catastrophic. It's not fundamentally not understanding.
Sorry. Do you prefer int main or void main?
Say again?
Do you prefer we do int main or void main?
I don't care. Well, I care if it matters. Nothing in this class doesn't matter. We're going to review more. All right. Okay, continuing on in our review for exam 3, which if you'll recall is next week. If you have a variable x, how do you declare and assign a pointer to the variable x? Next person, is that correct? And it is. Don't ask trick questions, I just ask straightforward questions. do the names X and P capital X need to bear any resemblance to each other from a language definition perspective? If I instead called it the name ABC, would it matter at all? It would not. You're right. It would not. Therefore, does there need to be any relationship between this name and this name? No. You can pick whatever name you want. Hopefully you'll pick meaningful names, but it's just a name. Next person. If I wanted to declare a function that took a reference to X as a parameter, how would I declare such a function? Call the function F. Here, I'll do the easy one for you. Function name is F. We'll call it a void function. We don't care about that. I want to pass a parameter that is a reference to an integer variable. What do I put? That is a reference to a variable named X? Or a reference to an integer variable? How do I declare a parameter that takes a reference to an integer variable? Does the name need to be X?
No.
It can be anything, it's just a name. That is correct. Now we'll come back and define it here a little bit. If I wanted to call F and pass a reference to X to it, how would I do it? This is pretend like this is one continuous program. And F is declared above int main, okay? So if I want to call, and these are declared, if I want to call F and pass a reference to X to it, how do I do it? That is correct. Since I have a pointer variable that points to X already declared and assigned, what's another way I could do this? The name is P capital X.
PX, yeah.
What do I put here?
Wait, are you calling?
Yeah, you're calling it.
Okay, so no asterisk then.
Because this takes a pointer, and X is not a pointer, it's an integer variable. This takes an integer pointer. So reference to X creates a pointer. In the case of PX, you've already created a pointer and assigned it, so you can just pass the pointer directly. Inside this function that I have called with some integer reference, I want to assign 13 to that integer. How do I do it? Can we make life simpler and more clear? I'm sorry, star ABC what?
113.
That is correct. What is the star doing?
References the location of the variable.
Nope. Oh, yes, it does. What's the term for this star operator?
Oh, asterisk.
What's the term for this asterisk operator?
Dereference.
Dereference. That's exactly right. What is the name of the ampersand operator in this usage? The reference operator. Reference and dereference do opposite things. Reference creates a pointer. Dereferences the pointer so you can actually get to the variable. Okay, that's your brief review of pointers and references and things like that. I said go over it earlier. I just give you a little quick stuff. Go over this deeply and understand all this deeply. Make sure you know how it works, because it is important to you. That's assuming you're great on the exam is important to you. Which, given what I've seen, I'm not always convinced it is. But I hope it is. Questions?
So with the first, first method call of X, since you're not putting in a pointer variable, you're putting in the reference for the variable X, which is not a pointer. Once the end of the method, like once the method ends, is asterisk ABC still, does it still exist, or is it out of the scope?
So when you've exited the method,
Yeah.
ABC is out of scope. In fact, if you even tried to reference it, you get a compiler error.
Right. So then, is there any purpose in doing the first one, like this example?
It's just two ways of doing the same thing. A case can be made that doing the second step makes things a little more clear. Right? Oh, I'm creating a pointer because this function requires a pointer. I've explicitly made a pointer, now I want to pass it. Takes slightly more processor time, but not much. But your code is more clear. But they're doing exactly the same thing.
Could you explain why you didn't put the asterisk on the second function of pfx?
Okay. Px is what? What type is px? An integer pointer. What does this method need as the parameter? An integer pointer. Px is an integer pointer. This needs an integer pointer. So you pass an integer pointer. So, the question is, the real question is, x is not an integer pointer, but I can make an integer pointer by using the reference operator. The reference operator literally says, make a reference to x. Okay. Now, that is the end of Module 3. That is the material from the beginning of class up to now, right? All of it that you need to know for Module 3. At the beginning of class next week, we'll do specific questions. Now we're going to talk about structs. Struct is a shortened form of the word structure. Just like char, which I don't have up here, is a shortened form of the word character. It's meaningful, right? So struct is a shortened form of a structure. It means you're creating a structure. And we'll oftentimes use struct and structure interchangeably when we talk about these things. So a structure, right, is something that contains things. Just like your house is a structure, it contains rooms, furniture, whatever. Like your car can be considered a structure. It contains seats, drive engines, things like that. So a struct in C contains things. So you have to give struct a name. Let's just give it the name ABC. This makes ABC a type. So just like we have integers as types, we have floats as types, we have doubles as types, and so on, you can create your own types, and they are value types, by using the keyword struct and giving it a name. So, where do you put it? Yes, sir.
Is there a semicolon required at the end?
Right here?
Yeah.
Yes. Okay, so struct ABC. You put inside the struct, just like you put inside your house or your car or whatever, the things you want in it that you're keeping together in the struct type named ABC. So let's suppose you want to do int hours, float pay rate, float tax rate. That's just a structure that for some reason you may want to create. And there's more complexity that we'll get to as we go. Okay, so right now, let's just keep it simple. So let's suppose, so this is just a type. You haven't declared a variable at all. Okay? This is just a type, like an int, like a float, like a double. It is just a type. This is not a variable declaration. Suppose we want to declare a variable of type ABC. The way we do that is we say struct ABC, because that is the entire name of the type, and then we give it a variable name. Now we have declared a variable named XYZ of type struct ABC. Any questions so far? Okay. Now suppose we have I declared some other variable named hours, right? And I read into it from scanf an integer. Now, suppose I want to put that integer into the hours part of struct ABC named XYZ. How do I do it? Pretty straightforward. XYZ is the variable I'm updating. The part of the variable that I'm updating is called hours because I declared it over here as part of the struct. And then I just assign it a value. And that makes sense so far before I get into the niceties of this.
XYZ the hours is hours.
XYZ, which is of type struct ABC, has subfields in it. Hours, pay rate, and tax rate. So I can assign a value to that. Suppose I said 13. That's perfectly valid too. It doesn't matter what you're assigning to it, as long as it's an integer value. In other words, you have something that is more complex than a simple integer. It contains 3 pieces, an int and 2 floats. The way you address the pieces is you say the variable name dot period the piece name.
What I got confused by is that you put hours before and that's not an integer though.
What's not an integer?
Where you put 13 had the word hours there.
Oh, right there. Int hours.
No, I mean like before you put 13 you had hours there, so that's not like it's not an integer number though.
Sure.
Right?
It's right there. And I read a value into it. The fact that these have the same name is completely irrelevant.
Oh.
Because the scope of the name hours only exists in the context of this structure type. If I use hours outside of the context of this structure type, it is whatever it means outside of that context. That's why I did that deliberately, to make the nicer point. That I'm glad you asked the question, because that's one of the points I was going to make. Scope. Remember we talked about scope? This isn't exactly scope, but it is kind of, it is scope, right? The scope of this hours is only within the context of this structure. Outside of this structure, this is outside of the structure. I'm just assigning some integer value. That's outside of the structure. This name is relevant to whatever scope it's in. This is why scope matters.
If you pass xyz.hours to a function, and the function's defined above the main where the struct ABC was used, is it treated as a pointer or is it treated as an int if it tries to update that variable somewhere else?
If I pass xyz to a function, how?
So if you had
So let's just make a function. What am I passing? Where am I passing?
or without even doing that, the function on the left would be fine for that, right?
Well, let's just do this one.
Okay, so for void nf, couldn't you just put int x or something and have it be fine that it's an integer there? But if you tried to update xyz.hours
Oh, wait. What's the parameter here?
int
Int what?
anything x,
Okay. Int x. Now, somewhere down here, you have int main, you want to call nf. Okay, what is it you want to pass to nf?
technically anything is fine.
Yeah.
How about
but
13?
Suppose all that exists, what's
13, like just the number 13 is fine for this. And so the confusion is if in the body of the function you put xyz.hours equals x, would it be a problem if struct ABC was defined later than this function being written?
No.
It wouldn't matter as long as it's somewhere in the program?
Well, XYZ, right, is a variable. That variable has to be global in scope to NF. So for it to be global in scope to NF, it's of type struct ABC. So struct ABC would have to have been declared before your declaration of the variable XYZ.
But what if both of those are after the function is what I'm asking?
You get a syntax error.
Got it. Thank you.
Because it doesn't, well, first of all, it wouldn't know what XYZ is because it doesn't know what the term XYZ means if it's declared after.
Okay. And then is that true even if you pass xyz.hours as a parameter instead
Now
of
you
13?
change the question.
Yeah.
Okay, that's fair. Let's change the question. So what do you want to pass now?
xyz.hours you could even write, I guess.
Can.
Or int xyz.hours.
Can.
Okay.
This is a placeholder.
So int x and then below put xyz.hours. Oh, that wouldn't
Where?
matter. Okay, thank you.
No, I mean, no, this is important, right? So, in other words, let's suppose we put this back as int x, right? So are you saying we want to pass xyz.hours? Assuming xyz is defined before NF somewhere, has the scope so the NF, so that this call to NF can see it, then yes, xyz.hours is an int, because that's how struct ABC is defined. So it's an int. This method calls for an int parameter. We absolutely pass an int parameter.
Thank you.
It's a good question. That's one of the niceties we're going to get to. This is good. I like it when you ask the questions before I get to the niceties. It means you're thinking. And I like that. I like thinking a lot. My wife and children might say I like it too much. They may be correct. I don't always think. Sometimes I play with the cat until the cat decides she's not playing. And then things like this happen. And then my wife, the nurse, says, that might be infected, so I have to draw with a Sharpie a line around it to see if the infection grows. Right? Pluses and minuses to living with a nurse. Right? Plus is, she's taking care of me. The minus is, I look like this. Question?
Parameter passing with a struct.
Parameter passing with a struct.
We change the.
You mean you want to pass, you want to have a parameter type of the struct?
If you do function ampersand xyz and you want to set a value equal to hours, you don't use period.
Function ampersand XYZ. I'm not sure what that means.
Some function that takes a struct pointer.
Okay, so let's declare a function. Wait. And you want to take a parameter type of?
A struct pointer, ABC pointer, pointer ABC.
Like that?
And you want to set a value equal to whatever you input hours field. The hour field or whatever you put into the function.
So for clarity, because this is a pointer to a struct ABC type, right? To do anything with it, you have to dereference it. I put it in parentheses, so it's absolutely clear that this is the dereference, okay? So then I want to assign something to the hours part you said?
Yes.
What do you think I would put next?
Do we have to do that one?
Have to. That's an interesting question. As opposed to what?
Instead of period, can you get rid of the pointer, the asterisk, get rid of the parentheses, instead of a period, use the arrow operator?
Yes, you could. We haven't talked about that yet. We will eventually. I think. I have to make sure it's spelled in C and not C++. I know you can do that in C++. Because I confuse myself among the myriad of languages I seemingly know, I'll have to look it up. But I'm pretty certain C, arrow, hours works. But I have to look it up to be certain. This is the simple introduction to structs. Okay? There's more. There's going to be more. This is not on exam 3. Structs is not on exam 3. Structs is not on exam 3. but we need to start moving along, okay? So this is the first part of structs. To understand how they work, how you declare them, that a struct is really a type. Just like an int and a double, it's just a type. And then you can declare a variable of that type by saying struct ABC. Yes, the syntax is a little unwieldy, but it's certainly clear that you're declaring. Sir?
What's the size of it? Struct.
If you use the size of operator,
No, what's the size of the struct?
what's the size of struct? It depends on what the struct is made of, is defined to be. But the good news is, right, you can use the size of operator to find out. So just like you can say size of int, and it'll tell you how big an int is, you can also say, assuming you have that declared, and it will tell you.
What's the, should I put a variable for struct ABC?
Nope. That would give you a different answer. Maybe. Maybe not. It depends upon the contents of struct ABC. As we have this defined, and suppose we declared XYZ, right? If we just said size of XYZ, as it happens, the way this is defined, yes, these will be the same.
But I'm not getting is what's the use of struct in that example? Since it's
In this
basically the
example?
same, since it's the same, yeah, since it's basically the same as.
Same reason you never use size of int. Suppose you're making an array and you're using a malloc. You need to know how much memory to allocate. Suppose you want an array of 5 struct ABCs. So you say malloc, and then you pass to it 5 times size of struct ABC. Same reason you do the same thing with int.
Can we declare variables at the end of the struct before the semicolon, like we do with units?
Yes. But we're not going to get to that tonight. But we will get to that. But that's exactly correct. So don't worry about it for now. We'll get to it next time. We'll get to it probably almost immediately after exam 3. Everybody knows, no one has to ask, there's lecture after exam 3, right? Think of the class as a 3-day class all mushed together. So the Monday part of the class will be the exam. Then the Wednesday part of the exam will be more lecture. And the Friday part of the exam will be more lecture, right? That's what a long class is. It's just a week-long class with multiple days, all pushed together. When people say, what can I add after in the second week? Because you've already missed a week of important things. And that's the biggest reason, right? But the other reason is, you're not sufficiently organized and on top of things, to think you're going to be successful. But and it says this in the admissions and whatever guidelines. It says, if you want to add a class, go to the class the first night, or the first day, or the first class meeting. It says that, black and white. It's not hard. Follow instructions. Okay, any questions about the struct stuff we've gone over so far?
Just one more time to remember. What did the xyz.hours do again?
Okay.
Yeah.
This just assigned a value to the hours part of struct XYZ. In other words, XYZ has subfields of hours, pay rate, and tax rate. This just assigned a value to one of those subfields. You can think of them as subfields or subvariables or whatever the right word that makes you understand it is.
Can you have all subfields at the same xyz dot, or do you have to write in a different?
You mean, can I have a variable inside here of struct ABC?
No, there where it says xyz.hours, and you have xyz.hours, comma pay rate, tax rate.
Not valid syntax. You can't, can you say int x comma y comma z is equal to 13? Same thing. It's just a thing. All right, that's it for tonight. Let you go early so you can study.